right, so now that we understand our sig fig rules, we also need to know how to do calculations using sig figs. So first we're going to cover multiplying and dividing, right? We'll also get to adding and subtracting here in a second. But if you're multiplying and dividing, you're supposed to use the number of sig figs in your measurement with the least amount of sig figs in your answer. So if I have this first calculation here, 9.8 meters per second times 20.10 seconds, right? I should be able to come up with an answer pretty easily just using a calculator. So 9.8 times 20.10 gives me this answer right here, 196.98. But when you look at that number, you should recognize that there are 5 sig figs, right? Both of my measurements to get that number had less than 5 sig figs. There's no way that you can have more precision in your answer than you had in any of your measurements. So since 9.8 has 2 sig figs and 20.10 has 4 sig figs, and the rule says to use the number of sig figs in the measurement with the least amount of sig figs, I'm going to need to have 2 sig figs in my answer. So I'm going to need to round this number, and that's going to turn into 200. And I should have a unit to go with that. Since the seconds cancel, I just have meters. But I run into a problem here. I'm supposed to have 2 sig figs in my answer, but 200 does not have 2 sig figs. So this is where we learn that there are other ways that you can show significance, right? Even though that first 0 in 200 is not significant right now, if I want it to be significant, all I have to do is put a mark over the top of it. So you're going to have to use sig figs always, always. You got to make sure that your answer has the number of sig figs that it's supposed to have, in this case 2. So even if you do end up with that 200, you got to make sure that I know that that tens place is significant. The first 0 is, the second 0 is not. I put a mark over it just so you could know. So that would be my answer. Okay, the next one I'm dividing there. It looks like a density problem. 52.30 grams divided by 49.6. So I do that on my calculator real quick. And I get this answer, 1.054435484. Now, being a reasonable human being, you understand that I don't really want to write all those numbers. I can't possibly have that much precision in my answer. So I'm going to look at my measurements again and recognize that 52.30 has 4 sig figs. 49.6 has 3 sig figs. I need to use the smaller of the two as far as significance is concerned. So I need to round this answer here to that hundredths place, and I end up with 1.05 grams per milliliter as an answer. So when you're multiplying and dividing, you count your number of sig figs. Whichever measurement has the least that you use to get your answer, that's how much you're going to have in your answer. Now, adding and subtracting is actually different. You're not really going to count anymore, but you still can't have an answer that's more precise than any one of your measurements. So the rule here actually says use the number of sig figs in the least precise measurement in your answer. We're going to do it in a different way. We don't count anymore. Right? This first problem says 55.1 plus 12.74. Right? Both those are gram values. One of them goes to the tenths place, the other one goes to the hundredths. We talked about that before. We know that, right, adding this up is really not that difficult. So you can get an answer real quick here of 67.84. But we know that we need to round this, and you just need to know how. We talked about before how that first number, 55.1, would be less precise because it didn't give me as much information. It only goes to the 10th place instead of to the 100th place. So I need to round to that place, to that 10th place, because that's my least precise measurement. So once I round this answer, I'm going to end up with 67.8 grams. But again, I didn't count. I know that 55.1 had 3 sig figs and the 12.74 had 4 sig figs. So maybe that counting rule would have worked here, but that's not always going to work. So you got to make sure that you're just lining it up and rounding it to the least precise. Right? So it's whichever one has a sig fig that's farthest to the left, essentially, when you line it up, when you're stacking up numbers to add or subtract. The second problem here, 12.65 centimeters minus 10.2. I can do that also very quickly because adding and subtracting is not very hard. Hopefully you don't need a calculator for this. I end up with this 2.45 as an answer. But again, I need to round to precision. Excuse me. 12.65 goes all the way to the 100th place, and that 10.2 goes to 10th place. So I need to round to the least precise measurement, so I can only go to the 10th place on this one. So I'm going to get an answer that's 2.5. Right? You always have a unit, centimeters, to go with this one. But if you look at this one, counting didn't work this time. 12.65 had 4 sig figs. 10.2 had 3 sig figs. So if you're counting like you would do with your multiplying and dividing, you should have 3 sig figs in your answer, and apparently I rounded it wrong. But I did do this correctly because you're just supposed to deal with precision. Right? Don't worry about how many sig figs there are because that doesn't matter in this case. I know that my least precise measurement went to the 10th place, so that's where I'm going to round my answer. So don't do the same rules for multiplying and dividing and adding and subtracting. You have to differentiate between the two. The last example here, 9.3 milliliters plus 1.76 milliliters. If I add that up real quickly, I'm going to get this answer, 11.06. But again, I need to round it. And my less precise measurement only goes to the 10th place, so that's where I need to round. So I end up with this answer, 11.1 milliliters. Again, don't count. It won't work. You always just round to a place, to a given place, depending on the precision of your measurements. Okay, so hopefully that clarifies things.